particular advantage in SystemVerilog. So we have seen from the data type point of view. So there are so many new data types added in SystemVerilog, and what are the advantages of those data types, right?
Yes, ma'am.
Okay. So yesterday we are at like struct data type, then union, then class. So when we should go for this kind of data types, so when we are using array means it is like same kind of data type collection. It can be of byte, it can be of bit, but data types should be same. Let you want some collection of data types, then you should go with struct or union. Here inside the struct, you can declare int, integer, bit, byte, any kind of data type you can store. Different data types. Okay. Union also.
I have a doubt.
Yes.
I have doubt regarding the this. We saw that associated array, right?
Yes.
There we can we not save different data types in that? Let's say that we cannot save. Huh?
Okay, how we are going to declare the associative array? Byte, array 1, then here string. Means my index is of string type, right?
Okay.
So which data type I can store here? Okay.
I understand. Yeah, we can save only that type. Yeah, correct.
Yeah, you can store only byte type. Okay.
Yeah.
Just 1 minute. Okay, so but here what happens, like in the struct union, you can store different kind of data types. Okay, so how can we declare this? Let I want to declare the class. Okay, so class, then class name, let class name is my class. Okay.
Yeah.
Then here bit, some variable 1, byte, variable 2, string, variable 3, then end class. Inside it, you can declare also some methods. Methods means either task or function. Just 1 minute. Okay, so task or function. So here function void. Let you want to display something or you want to print something. Okay, print. Then whatever is your function. Then end function. Okay, like this you can store task also. Just 1 minute. Okay, so this is about your class. Okay, so now my question is why we are doing only class? We can use stock data type also, we can use union also. But what is the demerit with stock and union? That you cannot declare the methods. You can declare any variable, but you cannot declare the methods. Okay. So let I'm declaring one stock data type. Okay. Just 1 minute. So let
so instead of using struct, we can always use the class now, ma'am. We don't need that.
Okay.
We can eliminate the usage of.
I'm saying when to use that one, when to use this thing. So int byte, let bit variable 3. Okay, so this is how, okay, this is struct, this is my struct name. Okay, struct name is let my struct. Okay, remember like this you can declare for union also. And this is a static data type. Static means once I'm declaring this, okay, so here only 32 plus 8 plus 1, 41 bit memory will be assigned. Okay. Now I want to assign this variable 1, I have to write my struct dot variable 1. I can assign any value to here. Okay, but the thing is that it is the static data type. Okay, so if I need static data, okay, now here I cannot declare any methods, only data type. But inside the class, it is dynamic, plus I can declare the methods also. So which one I should prefer? Class.
Yeah, we can. Yeah, that's what. That is the. I was about to ask the same question.
Yeah, mostly we will be using class, but there may be some requirement that we don't have to go for dynamic small kind of operation. There we can go for struct. But for like big memory kind of things, we should prefer the class because we can create it and delete it. Here you cannot delete it. Okay. Next, between struct and union. So struct means at a time I can use this variable, this variable, this variable because total 41-bit memory is assigned. But if I'm using union, then only 32-bit memory will be assigned. So 32-bit means at a time I can use either this one or these two. At a time, I cannot use these two variables. Why? Because only 32 memory is assigned. So depending on our requirement, we can choose whether union, whether struct, or whether class. But mostly we will be using class data type.
Oh, okay.
Okay. So now
limitation is 32 bytes, huh? 32 bytes.
No, actually in union, what happens? Let I am declaring a union data type. So here I have explained maximum memory. What will be the memory assigned? That is the maximum of the data type. So this data type, it is 32-bit.
Yeah.
This data type, it is 8-bit memory. And this data type, it is 1-bit. So what is maximum? Maximum is 32-bit. That means to this union, only 32-bit memory is assigned. So can I use variable 1 and variable 2? Because both need 40-bit, but I have only 32-bit. So I cannot use these two things at a time.
Oh, okay, ma'am.
Okay, so depending on our requirement. So now coming to class, we have another advantage also with respect to class.
But why do they introduce that such kind of constraints, ma'am?
Yeah,
that is not usable, right?
But this is collection of different data types, right? We have fixed array. See, we have fixed array also. Maybe fixed array is not that much of use, but still for small operation, we can go for fixed array.
Okay.
Yeah, similarly like thing. Okay, if I need different data type collection, then I should go for this one. Okay. So now here,
if I understand correctly, can I repeat? Union is allocating the maximum data type size
yes,
for the memory. We cannot use multiple variable assignment because of the memory limitation. Is that correct?
I did not get you. Can you repeat it?
The disadvantage of union is, I'm telling my understanding of union.
Yes, yeah.
There is a disadvantage in the union because the maximum usage of memory is the limitation. Is that correct?
Yes, correct.
Based on the data type that we declare, the maximum is actually is suppose we let us say that the previous structure is now defined as a union. Let's say variable 1 is 32-bit, variable 2 is 8-bit, and variable 3 is 1-bit. Okay, so what you're saying is what you said, as I understand, is the actual size is 32 plus 8 plus 1, that is 41 bits. 41 bits, ma'am. Is that correct, ma'am? 41 bits.
See, actually, whole data, if I want to access 3 variables, I need 41 bit, right?
Yeah.
But in union, the memory assigned to this data type will be equal to maximum of all variable data, like all
which
variable memory. Yes.
Okay, ma'am. Which is 32 bits. So therefore, we cannot do it. Okay.
Yes. Okay. So now coming to class. So let here class, my class. Okay. Then I'm just assigning some variable 1. I'm not properly writing, just some variable 1, variable 2, some method 1, some method 2, then end class. Now, whenever I'm declaring this class, at this moment of time, no memory is assigned. Let here variable 1, its size is 32-bit and its size is 8-bit. So at this point of time, no memory is assigned to the class. Class, when will be memory will get assigned to class? When we create an object for it. So how can I create an object for it? So module, let my module or my test. So here class name is my class. So my class, then object 1. So here I have created or I have declared just, okay. Declare a object for the class. Here also I have not assigned any memory. So declaring the object for the class means what? Okay. I am giving you one document. What document? Then I am asking you, okay, do some changes according to my requirement. Do this kind of changes in the document. So you have one option that you just take the document and started changing it Another option is that you take the document, copied this document, and the copied version, you started changing the document. So which one is good?
The second one.
Second one, right? So that's what I'm doing. This is my original class. I am not doing anything inside the class. I am just making one copy of that class. Now this object one, it stores the handle for this class. Whatever the things are in this class, I can use with this object one. I'm just making a copy of that class. Now, whatever the operation I will be doing, I'll be doing with this object.
Okay. Okay.
It is like class handler. It is pointing to my class. Okay. So I'm just declare here. Okay. So now initial begin.
But you have declared inside the different module, ma'am. Module might just
see, actually, these things you can declare inside another class. This is one class. So inside that class, can I declare an object for this class? I have to declare the object outside of the class, right? Can I declare, if I'm declaring here only, then it will be error. What is my class? This class does not know what is my class. So I'll be declaring the handle outside of the class. So this should be declared.
That is correct.
So that outside, it may be inside another class. It may be inside another module. But remember, whenever we are simulating anything, we cannot simulate the class, because at the end, we are going to simulate only one module. Class, it is like one kind of data type. If you think that, okay, I have written a code, now I will simulate, I will get the output. No, it is just a data type. If you want to data type properly, declare it inside a module, then whatever the operation you want, you can get it. Okay, so that's why I have written inside a module. Okay. So initial begin. Now here I am writing object one equal to new. Now at this point, 40-bit memory will get assigned to the class. Okay, now I want to use that variable one. I can write object one dot variable one. I want to use the method one. I can write object one dot method one. Like this, I can use. Okay.
Yeah.
You got this part? Okay. So
now,
yes, so end class. Let after some time I don't want. So this is like assigning memory to my class. Let after some time I feel that no, now I don't need this class. That means I have to delete it. So I cannot delete the class. Why? Because class is just a declaration. It is not taking any memory. Memory is assigned to this object. I want to delete this object. Then I have to write object one equal to null. Remember this. Writing null means deleting the object. And writing new means creating the object. Here what will happen? Memory will get assigned and default value. They will take the default value. So here two things you have to remember. One is this new method and another is this new method. These two are different. This is used for dynamic array to create memory, and this is used for create memory for class. Okay, so now this is the one thing I got to know that about class, that it is dynamic in type. Okay, so that is one advantage. Next, another advantages are it is reusable.
Is there not any method definition, built-in method definition for deleting a class?
This is the null.
No, that is assigning a dot method. Is there any dot method?
No, like in dynamic
dot delete or something.
No. Assigning null means deleting the object.
Okay.
So now class, it is reusable. Why it is reusable? Due to your inheritance plus polymorphism concept. Now, what is the inheritance? I guess you have some idea on inheritance. It is on C also.
Yes.
Okay. So now see, I have one function. Okay. So this one function or some variable. This variable I need to use inside this class, inside this class, inside this class. There is let variable name is variable one, and I have one method m1. Now I need to use this variable one and this method one inside this class, inside this class, and inside this class. So one way is that whatever I have declared here, I should declare here, I should declare here, I should declare here. But this is not a reusable kind of things because I have already the function and method. So why I need to declare those things again? So what can I do? Whatever the variable and methods are there, that will be there. I will inherit this class from this class. So now this is my parent class and this is my child class. So what will happen? Whatever the methods I have inside my parent class, I can assign those inside my child class. Now let's take example of this class. So this is my parent class. So here I have variable 1, variable 2, method 1, method 2. Now I am writing child extends, okay, class, child class extends from my class. Okay, now end class. Okay, so now I want to create a memory for my child class. Okay, so module, but I am not writing the module part. Okay, simple writing the memory. So child class object, okay, then object to equal to new. See, inside my child class, I have not written anything, but if I want to assign, okay, I can use object 2 dot variable 1. This variable 1 belongs to where is variable 1? This variable 1 belongs to my class.
Yeah.
But as I have extended this class from my class, so I can use whatever the variables and whatever the methods are inside this class. So I don't have to again and again write those things.
We don't have to redefine everything.
We don't have to redefine anything. Okay. Simple, we have to define it inside. Okay, now just take a practical example. Now let you want to print some values. Let you have some 5 values, you want to print it. So you have to write $display statement for the 5 variables. Now instead of writing $display statements in each and every class, just define that display method here. We will see an example. Just display method here, and in each class you extend that from the parent class and just call the $display method. It will work. Just in simpler word, remember, whatever the variables you are declaring here, whatever the methods you are declaring here, you can use those things inside the child class.
Yeah.
Now no need to rewrite those things again here, and here. So lines of code will get decreased. Okay, so this is the concept of inheritance. Okay, so now there is another concept of polymorphism. Polymorphism is also like somehow some inheritance concept is there. So inheritance you understood. Now coming to polymorphism. This polymorphism concept we will be using in the UVM mostly. Okay. In polymorphism, what happens now? Inside your child class, sorry, inside your parent class, you have written one method, print method. Okay, what is my requirement? Here there is one method M1. Now inside this class, you want to modify that method.
Okay.
So how can we achieve this? Let directly what you are doing. Okay, I will explain with the example, but now just from theoretical point of view, try to understand. Now you have declared a method M1 here. You can directly use that M1 method here, no problem. Now let you want to add some things, some new things to M1. So what you have done, you have again declared here one M1 method. Okay. By doing this, what will happen? When you call the M1 method, it will call the method you have defined here. Okay. It will not call this method. So it is like overriding.
Yeah.
But what I want, these methods should be there. Only the new things I am adding, that should got added to this method. So this concept we can achieve through the polymorphism. So here I can declare this one as virtual. Whatever the functions I am writing now, or task I am writing, virtual function, virtual task, with the use of virtual keyword we have to write.
Where you are telling, ma'am, you are telling master. About virtual definition in the root.
Master. Yeah, in the master you have to write whatever the methods you are defining, you have to write using virtual keyword. Then only you can modify those function here. if you want to modify. So in UVM, what happens? We have library. In that library, actually in SystemVerilog, you want to print something, you want to copy something, you want to compare something, you have to write your own code. Okay.
Yeah.
In UVM, they have written print method, copy method, compare method, everything is written and stored in the library.
Yeah.
So now you just have to use that one. Now let there is some run method. Okay. You want to add something new to your run method. So what you will do, you will call that run method and you will add whatever you need. And that run method in the library, it is defined as a virtual. Like whatever the run method, that will be defining a virtual function.
Okay, ma'am. One question I have.
Yes.
One question, ma'am. Is it advisable to declare every
yes.
in the parent class, every function can be declared as a virtual function?
Yeah,
is that true?
It is a good
correct?
practice. It is a good practice. If you are defining, see, we may need to override it, or we may need to change it, or we may not. But defining it will not cause any error. Okay. So we can declare it, not a problem. And it's a good practice to declare those things. And once you are declaring it virtual, in its every child classes, let this function you have declared virtual here. By default, this function will be virtual here also. So in its child class, you can modify that one. Once you are declaring
okay, but in the suppose in the child class that M1 is not defined as virtual, then in the subsequent child class it will be it can be.
Let here you have not declared it as a virtual. You have declared it virtual here. So whatever the child classes from this class, they can have the advantage of polymorphism. This class cannot use that function as a polymorphism.
Okay, ma'am, but I cannot use the third level child class without definition in the first level, right?
No. Then nothing like that. Okay.
Oh, nothing.
So now
we can go to any.
Okay. This function is not declared here. Okay. Now this not declared virtual here. You have declared that function virtual here. So this class also, see, remember, this class is not going to use this method as a virtual, because this is not virtual. So whatever you are writing here, now it will simply override that function. But its child classes can use. So polymorphism means that function will be there, but you will be adding. So in some point, what we need, while declaring the function, we don't know what can be the body of that function. So we will just declare with the virtual and we leave it. In the parent class, we will be declaring virtual and we leave it. So in the child class, when we'll come to know, okay, this is the implementation of this function, we have to add it. We can add them.
Okay.
So it is a good thing. In the parent class, declare those things as virtual. Okay. Understood?
Yeah,
so this is
so
due to class only, we can get the advantage of polymorphism plus inheritance. So this is the whole advantage of my class data type. Okay. So after this class data type, we will see what are the extra advantages in SystemVerilog. Next one is use of interface. Okay, so interface, it is the static component and it is the collection of wires or signals. Whatever the signals your duty have, same signals we are going to, like same number of signals we are going to declare here. According to your requirement, you can declare other signals also. This is like some collection of signals. So what is the advantage of having an interface? Okay, now let's see. Okay, so now this is my duty. Okay, so inside this duty, I have just used 3 other duties. Okay, so now we will see without interface what happens. Now you have some signals. Okay, so after you have completed your project, next after some time, someone said, okay, we should do some modification to my project. So when we are doing some modification, we may need to add some signals. Now here 3 signals are added. So depending on these things, you may need to add some signals here. You may need to add some signals here, and definitely you have to add some signals here. Right?
Okay.
Yeah. Understood this part? Now writing, so this is one way. Okay, if I'm adding some signals or I'm deleting some signals, then according to my requirement, delete it's not an issue, but adding definitely I have to add it. Okay, I have to check each and every module and I have to add it. So instead of doing these things, what can I do? I can declare an interface here. Now, whatever the signals I am providing, direct, like let I am designing an adder. Okay, so adder means sum will be equal to A plus B. So instead of directly declaring those signals inside the module, I'll be declaring the signals inside the interface. Now, instead of writing sum, I will be writing interface.sum equal to interface.A plus interface.B. That means I am connecting the signals through the interface. So whatever my A, B, sum are here. Now those signals I am directly, instead of directly giving, I am giving through the interface. So here what will happen? I need to add some signal. I have to add in the interface. Next, I have to do the connection. Instead of writing the signal name variable 1, variable 2, variable 3, I have to write interface dot variable 1. That means use the variable that is declared inside the interface.
Okay, ma'am.
So here what is the advantage? Addition and deletion of signals are easy.
Okay, yeah. We don't have to retype all everywhere in the code.
Exactly. Yeah, something you may need to, okay, where I need to declare those signals. If it is not declared in any module, go there and check it unnecessary. There will be so much compilation error. So if I'm declaring through the interface, it will be advantage. So here, simple addition and deletion of so any signal we need to add, we have to directly go to interface and we have to do. So something like whenever you are designing any project, okay, first thing to write the interface. We need to see what are the signals. Now, whatever the signals we are declaring inside the interface, we normally use logic keyword.
Okay.
Why logic? I have explained yesterday class. What is the advantage of having logic?
Well, we don't have to worry about whether it's a register or wire.
Yes.
And
during the connection, we will be connecting those signals to our duty. So we don't have to think whether this is my output, whether this is my input. If logic, it can work for input and output. But it will not work for in-out port, because in-out port has 2 drivers and logic has only 1 driver, means only 1 direction. Okay, so now interface. Inside the interface, we have another thing, mode port. That is extra thing added. So it simple defines the direction of the signal. That thing I will explain later. So simply remember direction of the signals.
Okay, ma'am.
Okay. So now interface part completed. Next one is my clocking block. Clocking block also we declare inside the interface. One is clocking block, another is programming block. So why we are doing these things? Okay. So remember in Verilog, we have race round condition between our duty and test bench. Race round condition between duty and test bench. Do you know what is race round or simple race condition?
Yes, ma'am. So let me explain. So when the clock is simultaneously toggling with the data at the same time.
Yes.
Okay, there are chances that metastability arises, ma'am.
Whatever you are saying, that is from the hardware point of view you are saying. Okay, I am particularly explaining from Verilog point of view. Race condition means simple, we don't know what will be our output, next output. Right.
Okay, I'll give an example, ma'am.
Yes.
Let's say there is an always block. So the output of always one block. First block is dependent on some signal, and the dependency of this signal is again in the second block. Actually, it is taken inside the second always block, and vice versa. Continue. So there will be a race around condition, feedback kind of thing.
So you are saying let I am writing A equal to B, then always at the rate passage of clock B equal to A.
Yeah, correct.
So okay. So here, okay. So here, why there will be race round condition? Can you explain me? You whatever you said that is correct, but why?
Yes, ma'am. It's every always block will happen at the same simulation time. So when you say A is assigned to B in the same at the same event, the second always block also executes and B is assigned A.
Correct.
So what will happen is
okay. So now we have do the example. Let A equal to 5 and B equal to 10. Okay, so now we have in Verilog, we have 4 different reasons. Okay, so active reason for simulation. Okay, for debugging point of view, these reasons are important. So active, inactive, then active, inactive reason, then NB reason, then postpone reason. Okay.
Okay, ma'am.
Okay, so now
this is in Verilog, huh?
This is in Verilog. In SystemVerilog, some new reasons are added. Okay.
Okay, ma'am.
So now here what will happen? This is the non-blocking assignment. So this will get executed here. Okay.
Okay,
So now,
okay.
see, remember LHS calculation will happen here, but assignment will happen here. Now here LHS calculation will happen. So A calculated value will be equal to B. B
10.
means 5. Now B calculated value will be equal to A. Sorry, B equal to 10. Huh? Now B calculated value equal to A. So that will be 5. This is calculated, not updated. If you want to check here, if you write $display statement, it will display 5, 10. Because it is decided that it will be 10 and 5, but it is not assigned here. It is not updated. Updated will happen here. Okay, so now A updated will be equal to 10. B updated will be equal to 5. So now when race round condition happens, whenever we don't know, okay, whenever the output is not correct. Okay, so depending on my simulation, okay, different tool, this always block may get executed first. This always block may get executed first. I don't know which one is going to execute. Both of these will start execution at 0 simulation time, and which one is going to execute first, we don't know. Okay. Now you just tell me whether this always block get executed first or this always block get executed first. Is this output is going to change? If it is going to change, then it is a race condition.
Yeah, the output will change.
Okay, yeah, now you say. Okay, now you just think. I just calculated these values thinking that this is executed first and this is executed second. Now just think this block will get executed first and this block will get executed second.
Yeah, yes, ma'am. So B is assigned A, which is B equal to 5, ma'am. Calculated, yes. B equal to 5, and A is then A is assigned B. So B's value, A's values is 10. So it is same. It is remaining same actually.
So okay. So remember whatever you said, that will happen whenever you are using blocking assignment. For non-blocking assignment, there is no race round condition here. But same thing, I am doing using, sorry, this is non-blocking assignment. Same thing I am doing using blocking assignment. Okay, so blocking assignment, the calculation happens in the active region.
We can copy paste in a separate paragraph. This is, don't change it, ma'am. Let it be. We can put as non-blocking topic.
Yeah, here only.
We have already. Okay.
Yeah,
okay.
See, these kind of things you should know, because whenever you are like debugging, okay, maybe by mistake you have done some blocking or non-blocking interchange. This kind of thing. Yeah. So you should know how blocking and non-blocking statements are getting executed. Then only you can debug the code. Okay, it is simple thing. Simple thing is that in NBA region, non-blocking assignment will be updated. In active region, blocking assignment will be updated. But these things plays a gate role while doing the simulation. Okay, verifying the things. Okay. So now here for the blocking. In the blocking, remember everything happens in the active. Calculated in the active, immediately it is updated. So first let's take this block get executed first. So A calculated equal to 10, immediately A updated to 10. Right?
Okay.
Now B will get calculated. Now what is the A value now?
Ma'am, A calculated value is 5 now, ma'am. Initially.
Okay. Here A equal to B. So what is B value?
B updated value is 10, but A calculated value is 5 initially, no? That's correct?
No, I'm not getting. See, I'm talking about blocking assignment. Actually, non-blocking, what happened? It is just calculated. Update happened in the NBA region. Okay, here. This is my active, inactive, NBA, and postponed. In the first case, it is calculated here, but it is updated here. So whenever I am writing $display, it will check these values. So here, even if I have calculated, but still it is not updated, so it is going to show me the previous value, A5, B10.
Okay. Okay.
Now in the blocking, what will happen? A is calculated here. Immediately it is updated here. So if I am writing $display, so it is going to display the updated value.
Okay, ma'am. Got it.
Understood?
Yeah.
Okay. So now here updated value equal to 10. Okay. So now what will be the B calculated value? Tell me.
B is equal to A. No? B equal to 5.
Why B equal to A? So now what is the updated value of A?
A is 10. So B is again 10.
10. B calculated will be 10. Immediately B updated will be equal to 10. Understood?
Oh, okay, ma'am. Okay, ma'am.
Okay. So now this is for, I thought that this block get executed first.
Okay,
now just think this block get executed first.
Okay, I'll tell you, ma'am. I'll tell the answer.
Yeah, tell me. Yeah.
So first B is equal to 5. B calculated equal to 5 and
5.
B updated equal to 5.
Correct.
And next thing is the second always A is equal to B value, so which is equal to 5.
Correct. So now
B
here
updated.
total 5. Now here depending
A updated. A updated.
Sorry. No, A updated. So now depending on which always block get executed first, I'm getting different output.
Oh, okay, ma'am. Yeah.
So this is the race condition. So whenever this kind of dependencies are there, don't use blocking assignment. In your tool, maybe with the blocking assignment, you are getting correct output. But this code, if it is like simulated or in different tool, then maybe depending on the sequence, I may get different results. So avoid this kind of things. So when race condition happens, okay.
So what is the most advisable way of coding, ma'am? Non-blocking, huh?
See, advisable coding guidelines are there. There are also like in Verilog, so many things are there. Okay. So when I should use non-blocking? If you are designing a sequential circuit,
yeah,
use non-blocking. Okay. Maybe with the blocking, you may get the correct output, but again, synthesis point of view, you will get different output. Okay. Next, whenever dependencies are there, use non-blocking. Now blocking, use when you are designing combinational circuit.
Okay.
Now avoid race condition situation. You have to check whether there is any race condition or not. And don't mix blocking and non-blocking. Let you designing one sequential circuit. There you may need some combinational blocks. So write combinational logic in different always block and sequential logic in different always block. Don't mix them up.
Okay, ma'am.
Okay.
Yeah.
So okay. So I was So race condition means when two or more events get executed at the same event region and we don't know the order of execution. And depending on order, results are different. Okay, so now what happens in Verilog? Your duty is written in module. Your test bench is written in module. So both the modules are get executed in the active region. So we don't know whether duty is going to execute first or test bench is going to execute first.
Okay.
Definitely depending on their order of execution, we will get different result. Let first, okay, so what is our requirement? Our requirement is that this is my test bench. This is my duty. So test bench should send value to duty and like first test bench should get executed, send value, then duty. Okay, this is our requirement, but let first duty is getting executed, then test bench, then also it is not an issue, because per first one cycle we may get some garbage value. After that we will be getting correct.
Call okay. One minute, ma'am. 1 minute, ma'am.
Okay.
1 minute. I'll do 1 minute, ma'am. Just give me a break. 1 minute.
Yes.
Sorry, ma'am.
Okay, no problem.
You'll continue. Yeah.
Okay, so and if let duty executed first and TB is executed second, then also not issue. According to that, we can adjust our code. But the thing is that we don't know the order of execution. Then it is issue. Yeah. In my tool, maybe test bench is executed first and duty is executed second. According to that, I have adjusted my verification and environment. I have written the code. When I am running in different tool, at that time duty is executed first and test bench is executed second. Then I may get the different results. So I have to make sure whatever the order of execution, I have to make sure that should be constant for every tool. In Verilog, it is not possible because I am writing both the things inside the module. But in SystemVerilog, what happened? We have used one programming block. And this programming block, it is executed in reactive region. This reactive region comes after the active region. Okay, first active, inactive, then reactive. So, and my test is written inside program block. That means I am making sure that first my duty should get executed, then my test bench. So in every tool I can run because I am just separating my duty from my test bench.
Okay.
Understood? So yes, programming block test is written inside program block, so it avoids the race between test bench and duty. Okay, so now coming
let me recall the same thing again. If I understand it correctly, you can correct me. There is usually in the Verilog we have the test bench and this thing written in separate modules. And when we execute it, we don't know the correct order of execution. Suppose the simulator will initialize first the test bench or the DUT. We don't know. So there will because of that there will be a simulation mismatch, right? That's what, right?
Correct. Yes.
Okay, ma'am. So now, so in SystemVerilog, they included the test bench to be written inside the to be evaluated in the reactive region. Am I correct?
Correct.
So and so there is something called a programming block where the test bench is written inside the programming block.
Yes.
That way we can avoid it.
So we are making sure that first duty, then test bench get executed. Their order of execution is constant for every tool.
Okay, ma'am. Okay.
So now clocking block. Okay, so like in sequential circuit, we may be working with passage of clock. We may be working with negate of clock. So some values we need to provide with respect to passage of clock, and some values we made to provide with respect to negate of clock. Okay, so instead of writing individually, we can write a clocking block. Clocking, let some CB. Now here at the rate passage of clock, then and clocking. Okay, so now here I can declare some signal 1, signal 2, signal 3. So here if I'm writing signal 1 equal to 10, okay, CB dot signal 1 equal to 10, that means this signal 1 is assigned with respect to passage of clock. So, okay, but in Verilog, how we are achieving this at the rate passage of clock, signal 1 equal to 10.
Yeah.
So now instead of writing this, we can declare all the signals inside one clocking block and we can use this. It is like synchronization advantage. Okay.
Okay, ma'am.
Okay. So now next is most like advantage of SystemVerilog, like if I'm going to like what is the topest, first one will be class concept, secondly it is the constant.
Polymorphism. Okay.
This polymorphism comes under class, but these are the important things. Like constant means you will have one verifications that is known as constant driven verification. Now what is this constant? Okay, now let you are verifying one encoder.
Yeah.
Now what you said, let's a simple 4-bit encoder. Okay, now you just written inside your test bench your input equal to $random.
Okay.
You repeated it like 30 to 40 times and you are getting correct result. So you said your verification is completed. But what is my question? If it is a 4-bit encoder, then I must check with 0001, 0010, 0100, 100. I don't care what are the other input you got or you generated, but I want that this input must be generated.
Got it, ma'am.
So how can I achieve it? In Verilog, okay, to randomize the things, we have just $random. Let I want to generate data between 20 to 30 or greater than 30 or even data or data, then we have to write lengthy codes there. But here in SystemVerilog, we can achieve this using constant. If you have remember, I have given some code with respect to constant. That is like some kind of scenario. Just think of an Ethernet. In the Ethernet, we have one header file. In that header file, I'll be sending the length of the packet. Okay, so now depending, I am sending length of the packet is equal to 50. So that 50 number of packets should get generated. How can I make sure that only 50 number of packet get generated? Using constant. Let I need that how many packets are getting generated, their summation should be less than 2000. That I can achieve using constant. Okay, so constant means I am giving some condition. According to those conditions, generate the input.
Okay. Got it.
According to some condition, generate the input. And these things are recur. Why? See, because this encoder 4-bit, even if you are generating all 16 combination, it is not a issue. But let you are just checking a big encoder. Okay, like 2 to the power 20 or 30. So if you are just generating all the combinations, then it is like simulation will get slowed because all the combinations I don't need. I just need the combinations like this. So I have to make sure that these combinations are getting generated. Okay, so I can write a constant for it. Okay, so constant according to some condition generate the input, and here we are using randomization method. In Verilog we have $random. That means we can randomize only a variable. But using randomization method, we can randomize a object. Now let you want to randomize 20 variables. In Verilog, you have to write $random 20 times. But in SystemVerilog, declare all 20 variables inside one class, create an object for that class and randomize the object. It will randomize all the, we will see the coding point of view, but here, so now this is one thing, random. Okay, so we have one constant driven verification. See, this verification, we have 3 kinds of verification. Okay. One is directed test case. So directed test case means directly you will read the specification. According to specification, you will generate the values. No extra values. Whatever written in the specification, according to that you have done. Now your project got completed. Okay, let in between the project, whoever was writing the test case, he left. Some new person came. So now what he have to do? He have to again go through the specification because all the test cases are written in directly. He have to again go to the specification, again study those things and write the test case. So it is time consuming. Direct test case, it can give you correct result whether you are properly verifying your environment or not, but it is time taking, right? You have to individually check it and write it. So next we have random verification. And in direct test case, what happens? We may miss some corner case. That is not inside your specification, but if this kind of combination arises, your duty may go to some unwanted state or unknown state. That is not
Okay.
written in specification. So we may not able to capture the corner cases. Next is random verification. In the random test case, what you are writing, you are not doing any directly things, just randomly you are generating the data. So there what happens, there may be a chance that you are hitting the corner cases, but
Yeah,
there is
correct.
also a chance that whatever the direct specification, you are missing that, because you are generating randomly na. So there may be chance that whatever is written according to specification, you are not generating those test cases. So next comes constant random. Okay, constant random test cases. So here what will happen, you will randomize the value, like I will be randomizing the object, but with some conditions. That means I will have directed test cases because I am writing the conditions. As I am randomizing the thing, I will have some random values also. So what is the advantage? I will be hitting whatever is written inside the specification due to constant. This is constant, okay, T. During the constant, I will be hitting the direct test cases, and as I have done random, so I will be able to hit the corner cases. Okay. So this constant, it is very important, and you should be able to write it properly. And like initial stage, na, as a fresher, like so many people are assigned this kind of, and not as a fresher also. Like let you are doing one project. If it is done from scratch, then you have to write the whole environment. Sometimes what happens, already the environment is there. They have added some new specifications. So you need to add some test cases and check whether with that specification, the duty is working fine or not. At that time, you have to write this kind of constant test cases. Okay. So now this is completed. Next one is coverage. Okay. So now in the input, okay, I make sure that these things should get generated. Okay. But how will be I sure that, okay, these things are generated? I have written those things, right? Okay, so how I will be sure that whatever I have written, it is getting generated perfectly or not?
By comparison?
If it is 4 value, you can compare it. If it is 1000 values, are you going to compare it?
No.
It will take time. So for that, I need coverage. So coverage, it is two type of coverage, code coverage and functional coverage. Code coverage, I will tell later. So functional coverage means these things engineers write, right? You have to write it. So in the functional coverage, okay, I have to declare some beans, and beans I'll be writing a simple write. I can write 2 to the power n. N can be 0, can be 1, can be 2, right? This is written in 2 to the power n format. Now, so this depends on my logic, what I am writing here. Okay. So here I'll be writing beans. Now my tool will check whether these beans are getting generated or not. If all these beans are getting generated, it will give you 100% functional coverage. If it is not generated, it will give you 60-65, this kind of functional coverage. We need 100% functional coverage. Again, it depends on the specification. Whoever is your client, if they are saying that with 95% functional coverage, it's okay, then you have to check up to 95%. Now, what is code coverage? Code coverage totally depends on the duty. Let here, you have written if A, okay, if select output equal to 0, else output equal to 1. So now let here your select value is like always 1. Then only 50% code is generated. This code is never going to execute, right? Because your select value is always 1. So here you have to check why it is not coming 50%. Okay, I have not generated. So if here select value is not getting generated properly, then you have to check your environment and you have to generate the select value equal to 1 also.
Got it, ma'am.
That is from
this is purely the design part. This is the design part we're checking. And again, what happens, there is some date code also. That code is not going to affect your design. Okay, designer has written those codes, but due to that code should get deleted. But due to some reason, designer has forgotten to delete the code. That is like dead code. But if dead code means that is no use in your design, but that code is inside your design means tool will check
that piece of code is never going to execute. So it will give you less number of code coverage. So you have to check. But what in
So
code
we have
coverage,
to remove that, no? We can remove it and make it 100%. No, that
you
is best,
can
no?
ask a design engineer. Okay, so these lines of code are never getting executed. Is it necessary? If they are saying no, this should get executed, so you have to generate input values according to it. If they are saying no, that is not
dead code means it's a designer part, no, ma'am. We cannot do anything.
No, this is designer part. So you will be the one who will be analyzing the code coverage. If code coverage is not 100%, you will come to know that, okay, tool will show that this part of codes are not getting executed. So first you have to check whether you have generated those values or not. If you have generated but still it is not getting executed, then inform designer. Designer will inform you whether this is correct or not. You cannot do the changes.
For dead code, it will be always coverage will be nil. No, I don't know. I'm not sure.
Yeah. It is, if it is a dead code, then designer will remove it. I just said one example. In case of dead code, you will get less code coverage.
Got it.
Okay. So now code coverage, it is totally done by the tool. But functional coverage is done by the engineer. So you have to properly write the functional coverage, because let you have 10 variables. Okay, so for 9 variables, you have written functional coverage, but 10th variable you have forgotten. So for 9 variables, you may get 100% functional coverage, but still that is not correct. Why? Because you have missed the 10th one. So it is very, are you getting what is the importance of the functional coverage? You are writing it. Code coverage tool will do. So there is no chance of less chance of error. But here you are writing. So it's very important to go through properly specification and write.
But I need an example to witness this writing functional coverage.
Okay. Definitely. I will be doing
later. We can do.
Whatever the project will be doing, their assertions, functional coverage, everything you will be doing. Not a problem.
Sure.
So this is the coverage. So this coverage we don't have in Verilog. So this is totally new to SystemVerilog. And next one is your assertion. We have one verification like assertion based verification. Whether your design is working fine or not, we can do with respect to scoreboard. In the scoreboard, we can write the logic and we can compare the output. But in my design, I have one condition that there is one FPB protocol. There is one condition that when P select equal to 0, P select equal to 1 and P enable equal to 1, at that time, address write data should be constant. Okay. Now this is one in your project. Okay, whatever you are doing, you are getting the correct output. Not a problem. Okay, you said, okay, I am getting the correct output. Coverage is also like approximately 100. So my design is correct. But there is a condition that whenever these two things are one, at that time address and data should be constant. But in your design, it is changing. So how you are going to capture it? We are going to capture it through the assertion. I will give you examples also, but remember this kind of scenario, if you say that, ma'am, I'll be writing with the code. No, like without assertion, I'll be writing these things. You may achieve this without assertion, but definitely it will take long lines of code. With assertion, within just one line, you can check whenever P select equal to 1 and P enable is equal to 1, at that time, whether address and data are constant or not.
Oh, okay, ma'am. Okay, got it.
So assertions means it is like protocol checking. Okay.
So the opposite of it is the effect of the opposite problem is because of randomization, correct, ma'am? Randomization is the problem here.
See, whenever we are writing something, we are verifying it. Okay. There may be a problem in the design. There may be a problem in the verification also. Verification
in the
environment.
Test bench writing. In the test bench writing, I'm saying, so, when we use the randomization, we cannot ensure that the vectors are correct, random vectors, but we cannot ensure that W data and address data are constant during the PCL enabling equal to 1. Correct?
Yeah. So we are not sure. Okay. So for that, we have to check these things. Okay.
Okay. Oh, this I think in our company, I think they have they are missing this. They're lacking this assertion. This thing, ma'am. I think so.
No, because the assertions will be okay.
I'm seeing a lot of #0 they are using, #0, #1, some delays and all they're using, which is not supposed to be used. No, ma'am. Correct, ma'am?
No. They can use, depending on the requirement, they can use those things. Not a problem. And assertion must be there. Any protocol, see, if you can see, like send some snaps of those code, I can explain why they are using. We can use depending on our requirement delay. Okay.
I was assuming that they're trying to force delay some #1, #2.
Maybe they may have that kind of requirement.
This is ideal simulation, not this is ideal simulation, ma'am. Zero delay simulation. RTL simulation.
Okay, zero delay. See, whatever delay, if we are adding with respect to gate, then it is maybe different. But even if with ideal simulation, we may need that. Okay, whenever I am sending my first transaction, after 10 nanosecond, I should send my second transaction. And after 30 nanosecond, I should send my fourth transaction. I may have requirement. I'm not saying that, but in your ideal simulation also, we give some delay between transaction to transaction.
Got it, ma'am. Okay, so this question on the APB example you gave, ma'am, this line, this same can be achieved using the FSM, right, ma'am? Correct, ma'am?
What I said, if you are saying no, I won't use assertion, I will be using some code. Okay, you can use it, not issue, but that will take much lines of code. If you're saying that, okay, you can use state machine, there is one way that whenever p select equal to 1 and p enable equal to 1, capture the values, then compare.
Oh, this is test bed. You're writing test bed. Sorry.
Yeah, then compare the values, whether those values are constant or changing. But again, this will give lot lines of code. So if I can achieve it with one line of code, then why to go for many line of code? Even if you are checking.
Can you give an example for this assertion, ma'am?
I will give tomorrow, next class, I will give example for assertion and coverage, all those things. And remember, okay, whenever you are designing a counter or checking a FSM, you want to check whether state transactions are happening properly or not. Like after state 1, then state 2, state 3, state 4, state 5, we can check it through assertion. And whether all the states are getting covered or not. I may have generated some values where state 1, state 2 are getting covered, but state 3 and 4 are not getting covered. Those things will be captured in the code coverage. In the code coverage, there is one functional coverage part. A tool will capture whether all states are getting covered or not. And where the state transactions are happening properly or not, that we can check through the assertion. So when you can say that your verification is completed, you will be getting the correct output, desired output, that is through your reference module or scoreboard. Output should be correct. If I'm doing a adder, I should get addition result. Okay. Next, I should get proper coverage. Whether it is code coverage or functional coverage, it should be, depending on my requirements, should be approximately to 100%. Third one, assertion. I should have no assertion failure. So these things I need to check.
Got it. Sure.
Okay, so this is total the advantage of like my SystemVerilog. So in the tomorrow class, okay, let mix up all the things. I'll be not going like as we go through the fresher because it will take much time. How to use a class, and using class, how to randomize the thing and how to generate like this constraint. Okay.
Yeah.
We will be seeing the tomorrow class, and there I'll be explaining like how to use class, how to use constructor, what is polymorphism, how to copy the things with respect to code.
Sure.
Okay.
Sure.
Okay,
Thank you.
Yeah.
Thanks. Bye.